Hello, everyone. Thank you for joining us in this session of Spokane Public Schools Keep Learning series for mathematics. Today's lesson is for students in grade 5, but all of you are welcome to join in. My name is Mrs. Henshin, and I'm a 5th grade teacher at Logan Elementary in Spokane Public Schools, and I will be your teacher for this lesson. I'm so glad you are participating with me today. You can access previous lessons on the KSPS website, and if you would like additional activities, you can go to Spokane Schools Learning at Home website. Sometimes it is helpful to go back and watch the other lessons in our series so you can continue to build your understanding of the mathematics we will be doing together. For today's lesson, you are going to need something to write on and something to write with, so go ahead and take a moment to gather those supplies right now. Great, are you ready? Here is today's learning target. I am learning to classify polygons, and we're actually going to have 2 learning targets within this. One will be with triangles, and one will be with quadrilaterals. Now, in class, we'd be getting out the geoboards, we'd be constructing these shapes, we'd be making them and looking at all of their properties. We'd do some fun shape sorts. That's a little bit harder to do on a video. So I want you to stick with me, and when you're done and you go back to all of the other things you can do besides the video lesson, you're going to find some pretty fun activities. Geometry is great, guys. You're going to really like it. Just stick with me. All right. So the first thing we're going to do is run through a couple of terms to describe triangles. So first, we're going to talk about angles. Acute angle is an angle with a measure greater than 0 degrees and less than 90 degrees. When I'm in class, I usually say it's cute because it's small and little. An obtuse angle is an angle with a measure greater than 90 degrees and less than 180 degrees. And then a right angle is an angle with a measure of exactly 90 degrees. And you can see the examples over here. A lot of times you'll see this little square right here because it has that 90-degree angle. And then by sides, we can look at triangles like this. Here's an equilateral triangle. It's a triangle with all sides the same length. Sometimes they're marked something like this so you can tell all sides are the same. An isosceles triangle is a triangle with exactly 2 congruent sides. So in this triangle, you can see these 2 have been marked because these are the 2 sides that are the same. And then obviously this one is different. And then we have a scalene triangle. It's a triangle whose sides are all of different lengths. The first, more specific learning target we are going to work on is I am learning to classify triangles. We're going to be classifying triangles in a hierarchy, which has to do with sorting and classifying objects on the basis of their properties or characteristics. At the top of this hierarchy is polygons. Polygons. What is a polygon? Do you remember? A polygon is a 2D closed shape with at least 3 sides. So the first way we can classify polygons is based on the number of sides, like triangles with 3 sides, quadrilaterals with 4, pentagons with 5, and hexagons with 6 sides, right? Okay, so if we move down and we're thinking just about triangles, the next thing that we can classify a triangle by is the side length. So with that category, we have equilateral triangles, all sides the same, isosceles triangles, 2 sides the same, and then scalene triangles with no sides the same. What's the next category we can think of? How else can we classify triangles? Exactly, based on their angle size. Okay, so within that category, we have obtuse isosceles triangles. 2 sides are the same, and it has that obtuse greater than 90 degrees angle. And then acute isosceles triangles, it has that acute less than 90-degree angle with 2 sides the same. And then a right isosceles triangle, it has that exactly 90-degree angle with 2 sides the same. And then for scalene triangles, we have those over here. We have a right scalene triangle. It has that 90-degree angle and no sides the same. An acute scalene triangle, we can very easily see this acute angle right here, less than 90 degrees and no sides the same. And then for the obtuse scalene triangle, we have this greater than 90-degree angle and no sides the same. Did you notice that we didn't do this for equilateral triangles? That's because with equilateral triangles, it's always acute. You will always have acute angles when all sides are the same in a triangle. Nice job with classifying triangles using a hierarchy. The second more specific learning target we're going to work on is I am learning to classify quadrilaterals. A quadrilateral is a two-dimensional flat shape with four sides. And over here you can see some examples of quadrilaterals. Do you recognize any of those shapes? Can you name them? All right, we're going to try that right now. Over on the side, I have a list of 7 different shapes. Okay, and you are going to try to sort them into the correct blank box over here. Let's read through each of the descriptions and then you'll try it out. So first, you'll try to find the word that matches any polygon with 4 sides, and then a quadrilateral with exactly 1 pair of parallel sides. Here, you'll put a quadrilateral with 2 pairs of parallel sides opposite each other. Here, you'll put a quadrilateral with 2 pairs of adjacent sides that are congruent. Then we move down to a parallelogram with 4 right angles, a parallelogram or kite with 4 congruent sides, and then a parallelogram or kite with 4 right angles and 4 congruent sides. Okay, so take a second and try to write down the words in the correct spot. Now you need to know a couple more words in order to do this, right? Congruent, adjacent. I think you can do it. You might remember them from maybe Number Corner early in the year. Okay, try it out and then we'll check our answers together. Go ahead. Okay, how did you do? Let's check our answers together, starting at the top. Any polygon with 4 sides. That would be a quadrilateral. How about a quadrilateral with exactly 1 pair of parallel sides? When it says exactly 1 pair, that means it does not have 2. It only has 1. What'd you put there? Did you put trapezoid? Awesome, nice work. How about a quadrilateral with 2 pairs of parallel sides opposite each other? That's a parallelogram. How about a quadrilateral with 2 pairs of adjacent sides that are congruent? Congruent meaning same length, right? That would be a kite. What about adjacent though? Does adjacent mean opposite each other? No, adjacent means next to each other. Okay, how about a parallelogram with 4 right angles? That is a rectangle. Good. A parallelogram or kite with 4 congruent sides. All sides the same. That's a rhombus. Okay, finally, we have a parallelogram or kite with 4 right angles and 4 congruent sides. Of course, that's a square. Nice work. Okay, let's take a little bit of a closer look really quick at some of these shapes. Here we have a square, and you can see it has the 4 right angles, and then all sides the same, 4 congruent sides. Now, what about a rectangle? A parallelogram with 4 right sides, and up here we see that a parallelogram is a quadrilateral with 2 pairs of parallel sides opposite each other. So that means opposite, opposite, those are parallel. Opposite, opposite, those are parallel. What about in a square? Is a square a parallelogram? Yes, a square is a parallelogram. Can a square also be called a rectangle? A parallelogram with 4 right angles? Yeah, but is a rectangle a square? A square has 4 congruent sides, and a rectangle doesn't always have 4 congruent sides, right? Okay, unless it's a square. Now, what about this shape? The trapezoid, a quadrilateral with exactly 1 pair of parallel sides. Can a trapezoid also be a rectangle? Can a rectangle also be a trapezoid? No, a trapezoid's kind of out there on its own, isn't it? Because it has only 1 pair of parallel sides. When a parallelogram, which a rectangle is and a square is, has 2 pairs of parallel sides opposite each other. And if you notice, they are not connected here, whereas these are all connected, right? Okay, how many of you have seen a parallelogram like this? A quadrilateral with 2 pairs of parallel sides opposite each other. What's the difference between that and a rectangle? A rectangle has to have 4 right angles, which this does, but this does not have 4 right angles, but it's still it's a parallelogram, and a rectangle is still a parallelogram because it has 2 pairs of parallel sides. So a square can be a rectangle, and a rectangle can be a parallelogram, and a parallelogram is a quadrilateral. So we can go up the hierarchy, but we can't go down because not all quadrilaterals are parallelograms, and not all parallelograms are rectangles. All right, nice work sorting those quadrilaterals. Let's do a quick true or false game. You're going to take a look at this shape at the top, and then you're going to answer true or false. I'll read them off one at a time, and then you're going to answer true or false, but also give me a reason why it is true or false. Okay, the first one, this shape is a quadrilateral. True or false, and why? Write it down. True. It has 4 sides. It's a quadrilateral. This shape is a trapezoid. True or false? Write it down. Okay. False. This has 2 pairs of parallel sides instead of just 1, like a trapezoid. How about this shape is a polygon? True or false? True. It's a closed 2D shape with 3 or more sides. How about this shape is a parallelogram? True or false? And don't forget to write down why. Go ahead. Okay, true. It has 2 pairs of parallel sides. It is a parallelogram. The shape is a rhombus. True or false? False. Not all the sides are congruent. See, this one's definitely longer than this side. This shape is a rectangle. True or false? True. It's a parallelogram with 4 right angles. How about this shape is a square? True or false? False. Definitely false. Not all sides are congruent. Awesome job on that one, guys. Okay, 5th graders, here is today's assignment. Make sure you communicate with your teacher on how they want you to turn it in. So you're going to be using these diagrams on the left, parallelograms, not parallelograms, to help you complete the assignment. Number 1, you'll need to list 3 properties of a parallelogram. Number 2, fill in the bubbles beside the other names that fit all parallelograms. Number 3, add 1 shape to each of the diagrams at the top of the page, but really here it's to the left of the page. Number 4, why can't trapezoids be classified as parallelograms? You'll just need to write out a response there, make it a complete sentence. Number 5, circle the words to tell if each statement below is true or false. Okay, if the opposite sides on a parallelogram are parallel and congruent, then rectangles are parallelograms, true or false. If rectangles have 4 right angles, then all parallelograms must be rectangles, true or false. C, if parallelograms have 4 sides, then all quadrilaterals must be parallelograms. True or false? Again, connect with your teacher on how they want you to turn this in. I will give you a moment to copy this assignment down. Okay, fifth graders, thank you so much for doing math with me today and all of the other days that we've been learning together. I'm so proud of you for continuing your learning at home. Keep it up.